All right, guys. So I want to finish up a little bit with our volume unit, okay? And namely, we're going to finish up with just actually what we refer to kind of as big volume problems, okay? So the big volume problems are usually a part 4 on the Regents. They're worth 6 points, and they definitely have many steps to them, okay? So this first problem, I'm on page 41. Number 14 was from a Regents exam, and it was a water tower picture. And it was a water tower that they told you was made up of a cone, a cylinder, and a hemisphere put together. And then they showed a cross section of it, right? So remember, the cross section of a cone is going to be the triangle on top. The cross section of the cylinder is the rectangle, and the cross section of the hemisphere is going to be a semicircle. And they give you a couple pieces of information that they label in the picture, right? They give you that from A to C is 8.5 feet, B to F is 25 feet, the angle DFE over here is 47. And then not really much steps. It says find the volume of the water tower. So it's kind of like a composite volume where you have to add the volumes of a few things. So for this one, to find the volume of this, we're going to have to find the volume of a cone. We're going to have to find the volume of a cylinder, okay? And we are going to have to find the volume of a hemisphere. Okay, and then we're just going to add those things up at the end. Okay, so one thing you'll notice is, okay, so for the cone, right? So the cone is this part, right? So for volume of a cone, you will recall that the formula is 1/3 pi r squared h, right? So, and you look at that cone and for a second, you're like, well, I don't think I have either. But you actually do have one of these dimensions, because do you see down here, they were giving you from C to A is 8.5. The good thing about that is that's the radius of that hemisphere. So one thing, if you're given the radius of a sphere or a radius of a hemisphere, just keep in mind that that radius is the same radius throughout. So C to K is also a radius, which means I can label C to K as 8.5. C to B is also a radius. I could name it as 8.5. But now that I know these two are 8.5, because of the rules of rectangles, these two have to be 8.5. So I do know the radius of this cone has to be 8.5. Okay, now I need the height of the cone, right? And so that, remember, the height of the cone is this perpendicular distance. That I don't have, okay? So if I'm looking at what pieces of information I do have, though, is I do know that this is a right triangle, because that is a right angle. I know I have 47 degrees in that right triangle, and I have one of the sides. If you remember, and again, this is what the Regents does, it kind of combines a few different units together, is if we have a right triangle and we know one of the angles, it means we could use trig to find the side, right? And so there's a couple things you could do with trig, but this is the one I want, right? So if I'm gonna use SOHCAHTOA, SOHCAHTOA would be, do you see, again, I'm looking for the opposite. I have the adjacent in this right triangle. So this would be, again, this is what I have. So if I'm just pulling out this right triangle, right? I'm looking for that, which I would label opposite. I have this, which is adjacent, right? So I could do the tan of 47 equals opposite over adjacent, and then just cross multiply and solve, right? So when you cross multiply here, okay, you get 9 point. Now, let's talk about rounding, okay? As far as rounding goes, remember, the point of this problem is not to find the height. The point is to find the volume at the end. So remember, we're only doing this as an in-between step. So we always want to over round it, right? So the final rounding turns out to be the nearest cubic foot. So whatever, I'm just going to over round a little bit, and I get 9.115, right? And then that's going to go in as my height. Now, another thing to point out, I did not have to use, I could also, remember we also said law of sines will work with any of these. So remember, law of sines, if you wanted to use it, you do the side over the sine of the angle across from it equals the side you have over the sine of the angle across from it. We know this angle because we know that's 90 and 47. We know that that's going to be 43, right? So again, if you cross multiply on this one and solve, you're gonna get the same answer. So it's up to you. You could do SOHCAHTOA, you could do law of sines. Either way, you're gonna get that 9.115. Now, same thing, that's only the volume of the cone. So I do also wanna overround that. Okay, so I'm just gonna go 2 places. 2 places should be good on this because I only have to round to the whole number at the end. So I'm at least going 2 extra places, right? Okay, so next thing we're gonna do, we're gonna move on to the cylinder, right? So the cylinder is here. So if we look, if you remember, cylinder is just pi r squared h. So for this one's pretty decent because I actually have everything I need. I know that the radius of the cylinder is 8.5. I know the height of the cylinder right here I was given was 25. Okay, so again, I'm just gonna overround that. That's like, type it into your calculator, you get 5674.50. Okay, then I'm gonna move on to the hemisphere. So remember, a hemisphere is 1/2 of a sphere. So it's 1/2 4/3 pi r cubed, which is the same thing as 2/3 pi r cubed. This one's another easy one because we do know the radius. We don't have to find anything on this one. Type this one into your calculator and you get 1286.22. Okay, so your final volume then is going to be the total of these 3 volumes. Okay, so we're gonna add these all up, and at that point you're gonna round to the nearest whole number on this one. So the total volume ends up being 7650, and the units, you don't need to write in the units, but the units would be feet cubed because all of these dimensions were in feet. Okay, so again, it got a little fancy with having to do a little bit of trig in there first. Okay, but they do that a lot in these volume problems. They do throw in a little bit of trig. Now, again, these are part 4s, which means it's not just going to be the volume. There is going to be some sort of follow-up question to this, right? So the follow-up questions can vary. Sometimes it has to do with like how fast you can fill it or things along that lines. This one says the water tower was constructed to hold a maximum of 400,000 pounds of water. Then it tells you that water weighs 62.4 pounds per cubic foot, right? So we know 62.4 pounds equals 1 foot cubed, okay? Can the water tower be filled to 85% of the volume and not exceed the weight? Okay, so we actually have 2 things to do here. We have the volume, we have to convert it to a weight, but we also only need 85% of that weight. To be honest, it doesn't matter what order you do it in. You could do the 85% first and then convert it to pounds, or you could do pounds and then convert it to the 85%. It doesn't make a difference, okay? So we already know the total volume, right? So we might as well just start with the fact that we only want 85% of the volume, right? So 85% of the volume, you could either do 0.85 times the volume you just found, okay? Or if you don't like that, you could always set up a proportion, right? So remember, the proportion would be 85 over 100 equals x over 7650. However you do it, you do get that that answer is 6502.5, right? So now that's 85% of the water, right? Now this is in, but again, this is still feet cubed, right? So we want to convert this to pounds, okay? So same thing, we're given here that 62.4 pounds equals 1 foot cubed, okay? So to convert my feet cubed, all I would really have to do is multiply, right? So I could take my volume, which is 6502.5, multiply it by 62.4, okay? And just see what we get. You could also, same thing, you could set up a proportion. If you don't realize to multiply on this one, you could set up a proportion with the conversion. You could say 62.4 pounds equals 1 foot cubed. How many pounds equals 6502.5, okay? Either way, you get a weight of 405,000. It doesn't really matter what you round to on this one because once we see it's over, right? It's over 400,000 pounds, then the answer would be, it says, can we fill it? The answer would be no, okay? Because it's over, that's right there is over 400,000. Okay, so there is always going to be some sort of follow-up question. Notice again, we had to convert units here. They do, again, we don't have to worry about it this year, but they were big fans of within a volume problem, converting units, throwing in trig, converting units, okay? All right, I want to do one more. There is, and so like if you look at the next one on the next page that you could practice on your own, it was similar to where you have a bunch of different shapes and there was also some trigonometry in there where you had to find the volume. Now the other one I would like to do is on this one on page 44, okay? So page 44 starts off with it's looking at like a cup, right? And they're saying the way you get a cup here is you start with this cone and you basically just cut off the bottom of the cone and the shape that would remain would look like a cup, which makes sense, right? You cut off that bottom and you get this little cup shape, right? So it's like a cone with a flat base instead of a pointy base. They call it, the fancy word for it is a truncated cone, okay? So if you look at this cone and you're given the diameter of the top circle, right? The top circle of the cup, the top diameter of the cup, and then you're given the diameter at the cut point is 2 inches, and then you're given the height of the cup, which is in between the bottom circle and the top circle, is 5 inches, right? And the first thing, they don't ask you to find the height, but what they do say is they say, why must these cuts, in order to find the height of this cup, right? Why must the cut be parallel? Okay, so it says the base with a diameter of 2 inches must be parallel to the base with a diameter of 3 inches in order to find the height of the cone. Explain why. Okay, so why must this be parallel? Okay, well, again, when we look at volumes, right, we kind of just in the previous problem where they made the cross section for us, we can break things down into cross sections, right? So if I were to do a vertical cut through this, do you see the cross section would just be this triangle with a cut here, right? So this is my 3 inches here, this is my 2 inches here, and from here to here we also know is 5 inches, right? So it's the same dimensions, but it's on a triangular cut, right? So you could either make it a full triangle, or if you want, you could just worry about the half a triangle here, okay, with the cut here. Do you see? So because this is going to be a right angle always, so I could either have this full triangle with another triangle inside it, or I could do this right triangle with this right triangle inside it. If you do that, the dimensions are different, right? This would now be 1.5 because it's only half of the top here. This will be 1 because it's only half of this 2 inches, but this is still 5. Okay, so it doesn't matter which way you think of the cross section, whether you think of it as full, regular triangles here, technically they're isosceles triangles, or right triangles. But either way, what you end up getting here is, because again, you get these cuts on right angles, there's right angles here also. Either way, do you see you would end up with similar triangles, right? This triangle right here would always be similar to the big triangle. We know they'd be similar, okay? If the cut were parallel, they'd have to be similar because you would get the corresponding angles congruent, and they already share an angle. So going back to similar triangles, you would get AA, right? So we would get the A from the sharing and the A from the two right angles, right? But that would only happen if you cut them parallel. So same thing here if you look at it as a right triangle picture. You'd have to cut them parallel so you would know these are congruent, therefore you have corresponding angles. So you could find the height of the cone, okay, because you would have, and again, by height of the cone, they mean the cone they cut off down here, okay? You could find the height of the cone if you know the triangles are similar because you could do proportions, okay? So that's why, so that's all you needed to kind of say on that first part, is that you end up with congruent corresponding angles and similar triangles. And then they ask you to actually find the height of the cone. Okay, so again, depending on which cross section you are. So let's say we're on this cross section here, right? So you have your similar, your big triangle and your little triangle that are similar, okay? So if you were gonna set up a proportion between the sides you have, right? So remember, we have to set up corresponding sides to find the height of the cone, right? So in the big triangle, well, yeah, we could start with the little guy, right? So in the little triangle, I have the top side right here is 2, and the height I'm looking for is x, right? The 2 in the big triangle corresponds to the 3, right? And be careful on this. In the big triangle, this height here is not just 5, because 5 only stops there. I'm going triangle to triangle, so we would have to say 5 plus x, okay? Same kind of thing if I use this one, right? So if I'm corresponding, again, the bottom right triangle to the whole right triangle, right? And I'm corresponding sides to do this proportion, right? In the bottom triangle, the sides are 1 and x. In the top triangle, the sides are 1.5 and 5 plus x. It doesn't matter which one you solve, you'll still get, again, you'll get the height no matter what. So either way on this one, when you solve, you get x is 10, right? So it doesn't matter which one you want. Now be careful, again, what they want. They actually want the height of the larger cone, right? So that's this whole thing together. So you found that this is 10, but your answer is, so the height of the big cone is 15. Okay, and again, it would be inches. You don't need to do inches because they said it in the question. Okay, so that was like a little funky with the similar triangles getting thrown in there, okay? And then, so that was like their extra question. And then finally, you're asked to find the volume of the glass. Now remember, so again, the volume of the glass, go back to your big picture, they only want the volume of this shape right here, okay? That's the actual glass, okay? Remember, the glass is formed by cutting off the cone. Now, that is not something we have a formula for. We have a formula for a cylinder. That's not a cylinder because the two diameters aren't the same. We have the formula for a cone, but that's not a cone either because cones come to a tip. So remember, when we don't have a formula for the shape we have, usually we could do a combination, okay? But do we see, but the previous problem, the combination was adding up the separate volumes. Do you see for this one, to get our weird shape, we're gonna have to subtract volumes we already know. Okay, so the volumes we're gonna look at, so we're gonna do the volume of the big cone first, okay? We're gonna do the volume of the small cone that we cut off. So if I start with the big, right? So that's this big cone right here, and I take off this cone at the bottom, I'd be left with the volume of the glass. Okay, so the volume of the big cone, okay, so remember, volume of a cone is 1/3 pi r squared h. So this is gonna be 1/3 pi. So I need the radius of the big cone, right? So the radius of it's not 3, it's 1.5. I need the height of the big cone. That's what I just found in the previous problem, and it's 15, right? For the small cone, I need the radius of the small cone, right? So it's down here, again, that's the diameter. So remember, the radius is 1. The height of the small cone is right here. We found it in the previous problem, was the 10, right? So all I'm gonna do is take these two volumes. You can just subtract these two after you get your answers, whatever. You can make them decimals. You could type them into your calculator as a big subtraction problem. But either way, when you subtract this volume minus this volume, you get, and again, this is where you want to look to see what you're rounding to. In this case, you're rounding to the nearest 10th. Okay, so what you will get after you do this math is 24.9 inches cubed. Okay, so a couple variation on some, hefty volume problems. Okay, so that is it. If the pages you can do are page 40, okay, that we didn't do. There's a big volume problem that starts on page 40, and there's another big volume problem on page 42. Actually, it goes into 43 as well, okay? So that will be your assignment for this week. All right, thanks guys.